Okay, 123, welcome to section 12, week 7. The good news is you already know the process. We are doing more unit conversions, factor label with unit fractions. The only thing we're doing is adding a few new conversions. A large part of this section is talking about gases, CO2 gas emitted into the atmosphere. Pollution is what they're talking about. And you don't have to know anything about chemistry. That whole section's on the chemical makeup. Don't let it scare you. It's just a conversion like we've been doing. So all you need to know, and it's on your sheet, are what equals what to make your unit fractions. Right here it says CO2 from gas, 19.8 pounds per gallon. So written just as a equivalency statement, 1 gallon of gas, my pen is failing me. Pens are failing me. 1 gallon of gas is equivalent to emitting 19.8 pounds of CO2 gas. Okay, then we go to CO2 produced from electricity. 1 kilowatt hour. So this one trips people up because you have 2 units here. Kilowatts per hour emits 1.37 pounds of CO2. So it is nothing new. It's just the factor label, just like we did last week, but using these conversions. Okay. So if we go to 1 in the homework, the gas tank of a Dodge Charger holds 19.1 gallons. So we have 19.1 gallons of gas. Anytime we're doing the conversion, we're going to need it in gallons if we're doing conversion from gallons to CO2 emitted when it's burned. How many pounds of CO2 are produced by burning the entire tank? Round to the nearest tenth. So we start out, it's not per anything, 19.1 gallons over 1 times, we're not cross multiplying. Right now, since we have gallons, we're ready for our conversion. We need to cancel gallons, so we need to put it in the denominator. Do that before you put the values. I've just already written it in. And pounds of CO2 would be in the numerator, what we're converting to. 1 gallon is equal to 19.8 pounds of CO2. We only have ones in the denominator, so all we're doing is 19.1 times 19.8, and we get 378.2 pounds of CO2 into the atmosphere. Number 2. They have an article and it tells us that 3.8 million gallons of gas each day are burnt from idling their cars. How many pounds of CO2 does this produce daily? Okay, so we're given 3.8 million gallons to pounds of CO2, a direct conversion. 3.8 million gallons over 1. You'd always start out with your units and then fill in the numbers. We need to cancel gallons since it's in the numerator here. We put it in the denominator of our unit fraction, and we're converting to pounds CO2. 1 gallon of gas, 19.8 pounds of CO2. That's from our conversion sheet. 1 gallon equals 19.8 pounds of CO2. We're just plugging it in. Multiply and multiply, and we have the word, it's in millions in your webworks, so they wrote the word millions, so you're just putting 75.2. Don't put the zeros because they're writing the word. Number 3. If a car gets 29 miles per gallon, how much carbon dioxide is emitted into the atmosphere when a car travels 85 miles? Okay, this one trips people up. Remember that we need gallons to cancel with our conversion, and we need it in our numerator. So they give you 29 miles per gallon is what your car gets. Because we need gallons in the numerator, we're going to need to switch that. There's nothing wrong. We can change this to 1 gallon over 29 miles. We know they traveled 85 miles. We're going to divide by the 29 miles. That gives us how many gallons we use. The miles cancel, and we have gallons. You traveled 85 miles. Your car gets 29 miles to the gallon. 85 divided by 29 is how we're going to get the number of gallons. Once we have the gallons, then we go to our next factor label. We're using our conversion. 1 gallon is 19.8 pounds of CO2. Gallon has to be, in this case, in the denominator because it's canceling this gallon times the 19.8, and this is the units we want. So 85 divided by 29 times 19.8, and we have 58 pounds of CO2. Okay, number 4. Now we're going to the electricity. From our conversion sheet, we have 1 kilowatt hour equals 1.37 pounds of CO2. Most of the time what they're going to give you is not kilowatts though. They're going to give you a watt. So you need to convert to kilowatts. 1,000 watts equals 1 kilowatt. Think of the metric system. This is our base unit. 1,000 base units equals a kilo. Okay. So number 4 says, how much carbon dioxide will you prevent from entering the atmosphere in 1 year? You got to read these time frames very carefully. If you replace a 150 watt light bulb with a CFL bulb that uses 17 watts in a light fixture that you leave on for 9 hours a day. Okay, so first to review a quick through things, there's 365 days in a year. There's 52 weeks in a year. 24 hours in a day, 7 days in a week. Those are things they're not giving you on your conversion sheet that you may need to use. So here we're starting out with a savings. It had a $150 watt, that's what we have. You're replacing it with a 17 watt. What is your savings? We'll subtract 150 minus 17. You're saving 133 watts. Okay. Now some people will figure this one and then subtract, but it's much easier to do it up front. So we have our given now. What we're going to convert is 133 watts into pounds of CO2. Okay. So the first thing we need to do is change watts to kilowatts. We need watts in the denominator because it will cancel with the numerator, and that will switch us to kilowatt up here. Now we need the hours. They told us it was used 9 hours a day. So I have 9 hours over 1 day. Now, how did I know to put hours in the numerator? Because we need kilowatt hours. We're using the kilowatts for 9 hours. So they need to be together. Kilowatt hours for 1 day. But then I got to convert days to years. Now I need to go to the numerator to cancel the days. 365 days in 1 year. Okay. Now, right now I still have this left. I'm ready for my conversion now because I need kilowatt hours in a numerator to cancel and go to pounds of CO2, and I've got it. Remember, there's two units down here in this conversion. That will cancel both of these. That's equal to 1.37 pounds of CO2, which is what we want per year. Multiply, divide, multiply, multiply, multiply. 598.6 pounds of CO2. You just have to go through very carefully with all the hours. What are they asking? Weeks, days, years, hours. Okay. Next one is 5. Now we go into vampire use. If you go to your page 103, hopefully you've pre-read your sections and watched the videos like you should. It is a whole section on energy vampires. This means what do certain appliances use even if they're not in use but they're plugged in. Like if you keep your TV plugged in, or a game station, TV, oven that has a clock on it, how many watts of electricity are pulled when it's not in use? So you have to either be given the hours that are not in use, or if you're given the usage hours, you're going to have to subtract that to find out how many aren't used. For example, if it was a day, there's 24 hours in a day. If it says it was used for 10 hours, then the non-use would be 14. 10 plus 14 is 24. And that is what is on this very first problem you have. Because it says the television was used for 5 hours a week. With vampire energy, we don't need this number. That's usage. We need non-usage. So how many hours are in a week? Okay. I shut off the recording a moment. I got a message that said my audio was not working very well. I tested it. Hopefully it's working okay. So here we were with 5 hours per week that it is used, but we need not in use. Okay. So how many hours are in a week? 24 hours in a day times 7 hours. This is the total hours in a week, 168. It's used for 5. So we have to subtract that. 168 minus 5 gives us the 163 hours not in use. Sometimes they'll give you that not in use, but a lot of times you'll have to subtract it out. Okay, so we need to start with how many watts per vampire standby energy for the TV is 3.06. You'll find this on page 103 in your book. This is the chart you'll use for vampire energy. So we have the 3.06 watts over 1. We need to get to kilowatt hours, so we need to cancel watts. Let's divide by 1,000, go to kilowatts. We just determined, now we need our hours. We're using it for 163 hours a week. Now we need to get rid of weeks and go to years, 52 weeks in a year. And this gives us what we need for our conversion, kilowatt hours, to cancel in the denominator. 1 kilowatt hour, that'll cancel these, which is what we want, is 1.37 pounds of CO2. And they want to know per year, so there we have our year. Multiply, divide, multiply, multiply, multiply. 35.5 pounds of CO2 a year. Okay. 6 is another standby. It was much easier. First off, they gave you, without going to the book, that it uses 8.8 watts when on standby. And it says it's on standby 22 hours a day. And they want to know how long for 5 weeks. So they're giving us the standby. We don't have to subtract on this one, making it a much easier problem. Okay, so 8.8 watts, we need to cancel the watts. So denominator, go to kilowatts. Then put in your conversion. 1,000 watts is 1 kilowatt. They gave us it's used for 22 hours per 1 day. There's what we need for our conversion. But they don't want to just know 1 day, 4 hours a day for 5 weeks. So I need to convert to weeks. I have my day, I need to cancel it. So in the numerator, 7 days in 1 week, weeks in the denominator, and it's 5 weeks. Now here's my conversion, kilowatt hours, and that's going to give me the 1.37 pounds of CO2 for the 5 weeks. And I almost did it again. That turns out to be 9.3 pounds of CO2. And every time I do this problem, they ask an A and a B. This is the final answer. In A, they just wanted to know how many kilowatt hours. So we just do this part before the conversion. 8.8 times 22 times 7 times 5. It's going to use 6.78 kilowatt hours. They did it in 2 parts. Then how much CO2 is that? We got our kilowatt hours, and we convert to 9.3. I did it all in one line because so often we do it, but they asked it A and B. Okay. And the last one in this section is very similar to the one we just did. The only thing about this one that's odd is it says, refer to your course materials about vampire energy. How much electricity is used on average by a garage door opener in 4 years? Now, what I had to figure out the first time was they're assuming it's on standby for 24 hours a day. Okay? Because then you get the right answer. They should tell you that. Okay? So if you look at your vampire sheet, a garage door opener is at the bottom here. 4.48 watts. Convert to kilowatts. 1,000 watts is 1 kilowatt. 24 hours in 1 day. There's what we're going to need for our conversion. And they want 1 year, 365 days in 1 year. But they want it for 4 years, so times the 4 years. And they don't want just the answer. First, they want how many kilowatt hours. That equals 156.98 kilowatt hours. And in part B, how many pounds of CO2 is that? We just take our 156.98, cancel our kilowatts, convert to the pounds of CO2, times 1.37 is 251.1 pounds of CO2. That is all for this section. Again, it is the same thing you've been doing. It's just adding 2 new conversions, gasoline to pounds of CO2 and kilowatt hours to pounds of CO2. And remember, most of the time you're given watts, so you have to convert it to kilowatts. Have a great day. See you in section 13.